Hi everyone, we're going to do an example of variable length subnet masking. This is for NET-200. And here's the scenario. I'm going to give the scenario on this page and do the addressing on the next page. So we have two routers, and let's say we have a WAN connection. This router has a network and this router has a network. Okay? Networks. We have one network here, another network here. They're both LANs, local area network. Okay, so we got one here, and we got one over here. So they're going to have to be on their own subnet. Okay? Then we also have a third network that needs to connect the two devices. Okay? Now in this network, we really only need two addresses. We really only need two addresses. Okay? So let's say we have this address to work with. 192.168, I'll just make this up, 10.0/24. That's what you have to work with. When given that, we're saying you cannot change anything here. So we have how many bits to work with? 8, right? 8 bits here. 8 bits to work with. So we can divide that up any way we want. And we know we need 1, 2, 3 network addresses. Okay? Now, what I didn't say was how many hosts on each one of these. We're going to work it out just to match these networks, okay? And we'll worry about the host later on. Okay? So, let's take a look at doing. So on this page, we'll do the subnetting. So let me write down that address again. 192.168.10.0/24. So we've got 8 bits, dot, 8 bits, dot, 8 bits, dot. Now I write these 8 bits out. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we know we need 3 networks. Okay? So we're not worried about the host today. I mean, you would be, but not in our example. Okay? So let's think about this. 3 networks. So since we're talking about networks, we're going to talk about borrowing bits this direction. And remember, we can't do anything with the first 3 octets. And our 4th octet, we can do with it whatever we want. We can subnet that whatever way we want in our example. So let's take a look. If we borrow 1 bit, that'll give us 0 and 1. That's only 2 networks. If we borrow 2 bits, that will give us 4 networks. Okay? And we need 3. So today, we'll do that. We'll borrow 2 bits to make sure we can get 3 networks. Okay? So I'm going to draw the line right here. So this is going to be the network. And this is going to be the host. So in this case, we'll have how many? 1, 2, 3, 4, 5, 6. 2 to the 6th, 64. So we'd have 60 hosts. Remember, all zeros here, all zeros here. If I put all zeros in there, that would give me a network address. If I put all ones, that would give me a broadcast address. So my combinations can't be all zeros and all ones. So instead of 64 combinations, we'll have 60. And then you're going to see how we may not work with all of that. Okay. We got 4 networks here to work with. Okay. So let's do it. Let's do the subnetting. I'm going to move fairly quickly here. So let me start writing the addresses down. So we have a 192.168.10. The first one would be, if those are both zeros, 0 slash, count them out. How many you got? 8, 16, 24, 26. There's a network. Next one, 192.168.10. Remember, you're going to give your combinations here. So I got a 0 and a 1. I have one group of 64/26, 192, 168. You're thinking here, right, while I'm writing? What's the next one? Really be careful now. I got a 1 and a 0. Right? 128. .168.168.10 dot. So we had 64 onto here, right? Right? We're going to have 128 and another one, which would be 64 onto that. Right? Is that right? 192/26. So, everybody with me here? Okay? And so I have 60 addresses for each of these. Now, here's what we want to do. Let's say we're going to assign this network to one of the LANs. Okay, we're going to assign this network to another LAN. And our third network is the communication between the two routers. I'll redraw that here. Okay, so what we can do is we can take, let's just take, for an example, this address, and we can subnet it again. So we can subnet it again. So now we have how many bits that we can use. This address, the 128 is, we've got these bits, right? These bits, right? We've got our 3 octets, and then we have this octet, which is right now a 1 and a 0. And that's where that one ends. So our network for that one currently is this. So we still have 1, 2, 3, 4, 5 bits to work with. So what we can do, we can subnet that again. We can take this network and subnet it again. And we can borrow, in this case, we're going to borrow 3 bits. And now we have 2 left in which we can make, we can make 4 combinations, but we'll only have 2 addresses. So we'll have 2 addresses at the end of that. And we can make 8 combinations, right? We can make 8 combinations, so we can make 8 more networks with 2 addresses each, knowing this is our cutoff. So to do that, let me go right in here. So we're going to take that. So now we have this network. So now it's like a subcategory underneath there. Okay, it's like a subcategory. So I've got, let me write it in brown here. So I got 192.168.10. And then if this is 0, 0, 0, then it's 128. That's the first one. /30. How'd I get 30? How'd I get 30? How'd I get 30? This is the network now, right? All the way to the end, which is 30 bits, because there's only 2 left for the 32. I'll write one more out, and then we'll be done here. 192.168.10 dot. This is really tricky. So what do? You put a 1 right here. If there's a 1 there of our combination of 8, what does that give us? That gives us 128 plus what? 128 plus what? 1, 2, 4. 132 is our next network, /30. So it'll go up by 4 each time. And you could then create these networks and then assign one of them to the interface. All right. That's it for today on this one.